All right, now the next section that we need to talk about here is nomenclature. So we're going to learn how to name aldehydes and ketones and also discuss some common names in there too. So this stuff is fairly straightforward. So as far as the aldehydes are concerned, we're going to find the longest chain that contains that aldehyde, CHO carbon. Of course, it'll be at the end for an aldehyde. That's your parent. We want a number closest to the CHO group. We're going to add the suffix al, so aldehydes in with al. And then we do all the other stuff. Add substituent names, appropriate numbers, consider R and S if it's somewhere in the molecule, and E and Z. That will give us the name of our product. So the other thing that we have to consider here too is that sometimes we have higher priority functional groups in molecules. And in that case, that CHO group is called a formal group. So we'll talk about that as we get through the nomenclature for aldehydes and ketones. So 2 carbons down here below, we have ethanol. Right, so eth, because it's 2 carbons, and because you have an alkane, and al because there's an aldehyde here. Well, let's take a look at this other molecule, see if we can name it together. So looking at this thing first, we count up the carbons 1, 2, 3, 4, 5. So we know that this is going to be pent. Now, it's not a pentane, it's going to be a pentene. And that ene occurs at carbon number 2. So it's a 2-ene, and now we drop that second E here. That's not included, so we get rid of that. But we still pronounce it ene. And that's pretty much it, right? So it's pent. Of course, it's an aldehyde, so we add Al here, right? But when we put that together, we get pent 2-ene al. Now we could also label this as being a 2-pentenal also. So the top numbering is kind of the newer way of doing this. And then we also have to remember stereochemistry here. So the H atoms here are pointing opposite to each other. So we could use, for opposite, we could use E for this, or we could call this trans in this case. So the other descriptor that we need to put in here is trans. So either of those names are IUPAC acceptable. Now, there are some common names that we need to be familiar with. So down here below, we have formaldehyde. Right, so the IUPAC of that is methanol. Ethanol, which we see up above, is usually referred to as acetaldehyde. So acet is a common name for 2 carbons. Think of acetic acid. Benzaldehyde, it's a benzene ring with an aldehyde group on it. Propionaldehyde is also known as propanol. And then butyraldehyde is kind of the common name for butanol. Well, let's take a look at ketones now. So ketones, again, pretty straightforward. So again, we find that longest carbon chain that contains that carbonyl group. That's your parent. We number so that the carbonyl gets the lowest possible number. And the suffix that we add here is -one, or ketones. Think of acetone. And then we do all the other stuff. Substitute names, EZ, RS, whatever else needs to be done. And just like before, if there's a higher priority functional group in the molecule that we're naming, then that carbonyl group of a ketone becomes an oxo group. And we'll look at an example of that down below in just a minute. All right, so let's practice naming a couple of these molecules here. So as we go through and name this first one, we count up the carbons. So 1, 2, 3, 4, 5. So I'm getting 5. Right? We're going to number this direction so that that group has the lowest possible number. Right? So 5 is pent, and it is an alkane, so it's a pent-an, and then -one. And that occurs at number 2. So it's a 2-pentanone. And we could also call this a pent-an-2-one. Again, both of those would be acceptable. So what about this cyclic structure? This cyclic structure is cyclopent, right? Cyclopentane. It has this ketone on it, so it will be, the parent will be cyclopent-an-one. Right, so we drop that E and add -one in here. Okay, cyclopentanone. Now that's understood to be at number 1 in this ring. So this is 1, 2. So that's at our 3 position. So it's going to be a 3-methyl. So when we put those together, it's simply 3-methyl cyclopentanone. Now, we're not done because we have a chiral center right there. All right, so remember, just a little review. Your H is pointing back there. We need to number these. So the H here is number 4. CH3 is number 3. This top side is my number 1 side, and this side is my number 2 side. So the order goes here from 1 to 2 over here to 3. So it's 1 to 2 to 3. I like to try to draw it out like this. I think it's clear. And when you look at that direction, that is the S direction. And then remember, we have to check and see, is number 4 pointing away from us? It is. So because of that, we leave it just like that. Okay, so when we put all of this together, we would just put a set of parentheses here with the letter S. You could call that a 3S, but it's not necessary to put the 3 because there's only one chiral center there. All right, so fairly straightforward stuff. So I want to take a minute and I want to talk to you guys about this idea of having higher priority functional groups on molecules. So we'll see this more, especially when we get into the chapters that deal with carboxylic acids. So chapter 20 and chapter 21 are carboxylic acids and their derivatives. So as a general kind of flow of ordering our priorities for our functional groups, over on this end we have higher priority functional groups going down to lower priority groups for nomenclature. So acids includes things like carboxylic acids. The thing to note here is that aldehydes have a higher priority than ketones. So if you remember, the aldehydes are formal groups and the ketones are named as oxo groups. Alcohols would be named as hydroxy groups. So if we look at this molecule down below, this first molecule, right, this is how you approach it. You say, okay, here you have a ketone, there you have an aldehyde. So aldehyde wins. So this is going to be named as an aldehyde. So naming this as an aldehyde gives us 1, 2, 3, 4. So it's bute, right? And it's butanal or butyraldehyde. Either of those are okay. So butanal, and then at 1, 2, 3, you have this group. That group is called an oxo group, right? So 3-oxo-butanal. And again, you don't need to number where the aldehyde is. It's considered to be at number 1. All right, so then looking over at this next one, let's see what we can do here. So here's how you deal with this. You look at this and say, okay, well, that is a carboxylic acid. Now, we don't know how to name carboxylic acids yet. So we'll learn that when we get into chapter 20. But we have seen this carboxylic acid before. This is benzoic acid. That's really the one that you need to know as you go through this chapter. So because it has a higher priority functional group than our aldehyde group here, we're going to name it as a benzoic acid. And then that group there is simply a formal group. And that group is at the 4 position or para. So then the name of this would simply be para formal benzoic acid. And there you have it. So the last section again here to look at is common nomenclature of ketones. And even though it says common, it's been incorporated so much into the language that they're considered to be systematic also. In this case, what we do is we name the carbon groups attached to the carbonyl and name them as alkyl groups. And then we put them before the word ketone, and that would be the name of our molecule. So looking at this, here's your ethyl, and then here is your methyl. So methyl ethyl ketone. Again, same thing over here. Here we have a methyl group, and that group right here, I don't know if you've seen it before, it is called a vinyl group. So methyl vinyl ketone, otherwise known as MVK. And there's also some common names too. Some of them we've used in lab before. So acetone. So we don't really call this 2-propanone. It's just acetone. Acetophenone. So remember, acete means 2 carbons. So you got your 2 carbons there. And then benzophenone is 2 benzenes connected to a carbonyl. So there's some labs where we use benzophenone to do some synthesis in our 225 lab.